Okay, so for our next problem we have 5m squared over n to the fourth power, and we're raising that entire statement to 0. And I know I keep giving you these problems, but this is one of the problems that people have a lot in this section, and it's one of the easiest problems we have, and we tend to get really confused on it. But again, I'm raising this entire thing to the 0 power, and anything raised to the 0 power is always 1. So this answer is 1. There's nothing outside of my parentheses, so there's nothing to multiply that 1 times. My answer is just 1. Okay, so again, we've got negative 3x over y to the negative 2, and we're raising that to the second power, the entire statement. So again, everybody in the parentheses is going to get this power of 2, the negative 3, the x, and the y. So this is going to become negative 3, and I'm going to place that in parentheses, squared. Part of the reason I want you to place that in parentheses is because you are saying that you want to take negative 3 and multiply times negative 3, and a negative times a negative is going to give us a positive there. So be real careful with those negative signs. And this would be x to the second power. On the bottom here we would have y to the negative 2 raised to the second power. Okay, so we can go from here. Again, even though he's a negative number, his exponent's positive, so he's perfectly fine where he is. We can go ahead and do negative 3 times negative 3, which gives us a positive 9. X squared is just fine where he is as well. And here we're going to multiply these two powers together, and that's going to give us y to the negative 4. Again, this y to the negative 4, he's got that negative exponent. He's not happy in our denominator. He really wants to be on the top of this fraction. So we're going to move him up and get 9x squared y to the fourth. Notice that I don't have a denominator anymore because the only term I had in the denominator was the y to the negative fourth, but I moved him up to the top, so I don't have a bottom, and I just have this answer, 9x squared y to the fourth. Okay, so for our next example, we have negative 4 over x y to the third power raised to the negative 1. So again, everybody's going to get this negative 1. So the negative 4, the x, and the y. So this is going to be negative 4 to the negative 1 power over x to the negative 1. And we have y cubed to the negative 1. Now again, I want to always simplify my exponents first before we start moving stuff around. So I want to take these two where we have a power to a power and multiply those together. So that's going to give us, still we've got the negative 4 to the negative 1, x to the negative 1, and then we have y to the negative 3. And again, we've got a lot of negative exponents. In fact, this guy on the top has a negative exponent, so he really wants to move down to the bottom. Both of these guys in the bottom want to move up to the top. So we're basically going to flip this fraction over. We're going to have x y to the third over negative 4. Now the only thing that we really need to do to correct this is we really don't like having negatives in the bottom of the fraction, so all we need to do is take this negative sign and just move him up to the top or move him out in front. Either one is perfectly fine. So we would say this is negative x y to the third over 4, and this would be our final answer. Okay, so for our next example, we have 3m to the third n over n squared raised to the third power. Again, what we need to do is we need this 3 to go to the 3, the m cubed, the n, and the n squared. So everybody's getting that power of 3. Remember, this is a power of 3, not multiplying by 3. So we have 3 to the third. We have m to the third raised to the third again. We have n to the third. And on the bottom, we have n squared to the third. Okay, so from here, we can go ahead and do the 3 cubed because our 3 to the third, because it's positive and it's happy where he is. So 3 times 3 times 3 would give us 27. Right here we are going to have a power to a power, so we're going to multiply those together. That's going to give us m to the 9th. We still have our n to the 3rd. And again on the bottom we have a power to a power, so we're going to take those and multiply them together. That's going to give us n to the 6th. Now we're almost done, except for the fact that we have two n's and we never want to have the same variable twice in a problem. So we do want to combine these guys together, and that is going to be using subtraction. Now again, you need to be very careful on your signs. So when you do this, you still have your 27 m to the 9th and then n, but watch what you're doing. We're doing 3 minus 6. 3 minus 6 is going to give us n to the negative 3. And it can kind of make sense because you have more n's in the denominator of your problem, but when you do the subtraction, it always moves it to the top. So notice that your n's are not happy. They really, really want it to be in the denominator because you had more of them down there to begin with. So we're going to move them down, and we're going to say our answer is 27 m to the 9th over n to the 3rd power. I just want you to remember that whenever you're doing the subtraction, it always moves to the top. Then you can look at your exponent and say, ooh, that's negative. He's not happy there. He really wants to move to the bottom. But be very, very careful with your subtraction. Remember, it is always the top exponent minus the bottom exponent. Alright, so for our next example, we have 2 to the 3rd power x to the 3rd y over y cubed, and we're raising that to the negative 2 power. Again, what we want to do is take this negative 2 and give him to every single one of these terms, both top and bottom. And notice this time we have 2 cubed and we're going to raise it to the negative 2. So we want to do it just like we did our variables earlier. So 2 cubed to the negative 2. We have x cubed to the negative 2. We have y to the negative 2. On the bottom here we have y cubed to the negative 2. And again, we've got a lot of double exponents here, a lot of power to power. So why don't we go ahead and multiply all of these powers to powers. We've got 3 of them here that need to be simplified down. Always like to have it as we only have one exponent instead of having 2. So this is going to be 2 to the negative 6, x to the negative 6, y to the negative 2 over y to the negative 6. And again, we did one like this earlier where everybody on the top has a negative exponent, everybody on the bottom has a negative exponent. So basically what we're going to end up doing is just flipping this fraction over. So we would have y to the 6th over 2 to the 6th, x to the 6th, and y squared. Now we're almost done. We've got 2 things we need to do to finish off this problem. One of them is that we do have 2 different y's. We have y to the 6th on the top, y to the 2nd on the bottom. So we need to combine those together. Again, since it's division, one's on the top, one's on the bottom, we're going to subtract those exponents. The other thing we need to do is we've got this 2 to the 6th. We need to simplify that down. So again, we're going to take these guys right here and subtract them. Remember, no matter what happens as far as the resulting answer, it always moves to the top. So this would be y to the 4th, and then 2 to the 6th, that's 2 times 2 times 2 times 2 times 2 times 2, that's 6 2's multiplied together. So that is going to give us 64 x to the 6th. Now remember, we don't have the y anymore because we subtracted the 6 and the 2 to give us that y to the 4th on the top. And this would be our final answer. So for our last example, we have 7 x cubed y to the negative 2, all being raised to the negative 3, and then we're dividing that by 2 x to the negative 1 y, and all raising that to the negative 2. So on the top of this guy, everybody's going to get this negative 3, just the top 3 terms here. So that's going to give us 7 to the negative 3, x to the 3rd to the negative 3, y to the negative 2 to the negative 3, over. Everybody on the bottom, however, is getting that power of negative 2. So for the 2, x to the negative 1, and the y. So this is going to be 2 to the negative 2, x to the negative 1 to the negative 2, and then y to the negative 2. Again, before we start talking about things being in the right place with the negative exponents, let's simplify down these power to powers. So we have this guy right here we need to multiply. This one right here we also need to multiply. And then down here on the bottom, multiply that as well. So I'm going to leave our 7 to the negative 3. Then we're going to have x to the negative 9 and y to the positive 6. Here on the bottom we're going to have 2 to the negative 2, x to the second, and then y to the negative 2. And again, anything that has a negative exponent needs to switch positions. So the 7 negative 3 needs to move down, the x to the negative 9 needs to move down, the 2 to the negative 2 wants to go up, and the y to the negative 2 wants to also go up. So again, just draw your fraction bar and move stuff around. So again, the 7 is moving to the bottom, and the 2 is moving to the top. X to the 9th is moving to the bottom, and x squared is staying in the bottom. So he was perfectly happy. So the x to the 9th we moved down from the top. The x squared stayed from the bottom. We've got that y to the 6th that's also perfectly happy in the top. But we're moving up that y to the negative 2, making him y to the positive 2. So now we just need to do a couple little cleaning house and simplifying some stuff down. First of all, 2 squared is 4. And 7 cubed, that's 7 times 7 times 7, and that is going to give us, I believe, 343. Yep, 343. And then we're going to take these two, since they're both on the top, that's through multiplication, so we're going to add those exponents. That's going to give us y to the 8th. And then the same thing here, we're going to multiply the 9 and the 2, and that's going to, we're going to add the 9 and the 2 because they're multiplied together, and that's going to give us x to the 11th. Now, if we could, we would reduce the 4 and the 343. One of the ways you can always check and see if you can is to come back up here to what we multiplied. 2 and 7 don't have anything in common, so neither does 4 and 343. So this would be our final answer.